Hello my dear students, how are you all? Welcome to our YouTube channel Diksha Karnataka. I am Ankit Sir bringing you another very important day of our series, which is nothing but the solution for our mock test 1, right? I hope you have all solved the questions and you're ready to get all the answers, cross check all the answers, right? Whether it is correct or not. So in this mock test we have taken almost every questions for relation and functions, and some questions I added for ITF also. In the coming sessions ITF will also be there for one more session of mock, but for today's mock the priority was given to relation and function, and some questions were added at the end to solve for ITF as well. Okay, so I hope all of you performed really well. Okay, let's get ready. Take a pen and paper out and cross check your solutions. Okay, and give yourself, for every correct answer you give yourself 1 marks, for every wrong answer or unattempted answer you give yourself a 0. Okay, so be honest and let's start with the session. Come on, let's take the first question. Okay sir, first question is, yes sir, what is first question? If the set X contains 7 elements and set Y contains 8 elements. Okay, quickly we'll do. Okay, if you just have to check your answers, I've given the answers over here as A. You can quickly take that and write it as +1. Okay, so if the set X, so Y +1, because I know you've all got this question right. Set X contains 7 elements, set Y contains 8 elements. So what it says is n of A is 7, n of B, no, it's not A and B, it's X and Y. It's X and Y, sir. Yes, sir, it is X and Y. So it is n of X is 7 and n of Y is 8. They are asking for what? Number of bijections. So we can't get any answer for this. The answer is A, right? Why is it A, sir? Because n of X is not equal to n of Y. For the bijections to be present, what has to be there? N of X has to be equal to n of Y. Why, sir? 1 1 on 2. 1 1 on 2. Remember this. 1 1 on 2. Every element will go with every other element in uniquely in the set B or the codomain, right? Or the codomain, and none of the elements in the codomain should be having or should be left out. Means I cannot have any element which is left out. So for it to be bijective, what should happen? Nx equals to ny, means number of elements in X equals to number of elements in Y. First question done, sir. Let's move on to the second problem. Okay, if A equals to, okay, X less than 5 for all natural number, okay, and you have this also, x square minus 5x plus 6. Okay sir, then the number of onto function from A to B, number of onto function from A to B. So let's quickly write A first. How will A look like, bacha? So A will look like this, sir. All the natural number from less than 1, less than 5. So 1 2 3 4 5, correct na? All natural number less than 5 is 1 2 3 4 5. What about B, sir? B will be, if you solve this, you'll get answer as -2 comma -3, correct? X minus 2, if you want to factorize this, you'll get x minus 2 times of x minus 3 equals to 0, correct na? Check here, -2 into -3 is +6. So that's correct, right? That's how we can check it. Last, if you multiply the constants, you should get the constant here. -2 minus 3 is -6. Again, x square will be there, and -2x and -3x will become -5x, sir. If you're not sure, make this multiplication and get your answer. Okay, do the expansion. So answer would be what here, bacha? Answer would be 2, 3. Answer would be 2, 3, right? So if you put x minus 2 equal to 0, x equal to 2, and x minus 3 equal to 0, x equal to 3. Two answers are there. Now they're asking us number of onto functions. Number of onto functions. What is the meaning of onto functions? So in the codomain, I cannot have any element left out. That's the meaning of onto function. Correct, sir? If you have missed the concepts, make sure that you watch the videos. Okay? If you are putting effort, bacha, put complete effort. Just don't come for one session, one video. If you have missed this concept, that how onto is defined like this, go and watch the session. So for onto, what is it? None of the elements in codomain should be left out. Okay, great sir, all right. So if I am going with that, then what we have to find out? Number of onto functions. So what is the number of function in this case? Number of function in this case is what, bacha? It will be 2 power 5, correct? How 2 power 5? Check, if this is n and this is my m, right? This is my n and m. I hope you know this. So this, for this I write what? M. For this I write n. So number of functions what will be what, bacha? It'll be n to power m, right? Now what will be this? So if I write this, so it will be 2 power, n is nothing but 2. There are 2 elements in B, and power 5 is going to be 2 power 5. So 32, I think 32. 2 into 2 into 2 is 8, into 2 is 16, into 2 is 32. Correct, sir. 2 power 5. What about, okay, but I can also have this situation now, bacha. So if this is my set A and this is my set B, how many elements are there in set B? Sir, you wrote so many. No, there is only 2, na? There is only 2, right? So there is only 2, bacha. What is it? That's 2 and 3. That's 2 and 3. What about set A, bacha? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I can have a situation which will be a function when function will be like this. Means all of these are having only 2 as the image. All of the elements of A are having only 2 as the image. So that can be one condition. This can be one such function. One such function. Okay. And for again I can have the same situation going for this. All the elements going for the second element, which is 3. Again I can have one such situation. Okay, so if you can see here, I am having 2 situations where okay, one second. So in condition 2, when I was taking only 2, 3 was left out. If I am taking only 2, 3 is left out. Is it onto? So not onto. Why not onto, bacha? Because I was taking only 2, 3 is left out. If I see the mapping of the white color, 2 is considered but 3 is left out, means not onto. Don't get into many 1 and 1 1. We are not talking about many 1 1 on 1. We are talking about onto function. So when I am looking at 2, the white mapping, sir, 3 is left out, not onto. If I am looking at 3, the green mapping, sir, 2 is left out. So again not onto. So both these conditions gives us 2 such functions where it is not onto. So total number of onto function will be what, bacha? So total number of onto function will be what? The total number of function which is 32 minus 2 such function where it is not onto. The total number of function which is 32 minus 2 such functions where it is not onto. So minus 2. Answer is what? 30. Answer is 30B. Answer is 30B. Okay, I'll move on now. Chaliye. Question number 3. A relation R. I hope you understood the previous one. If not, go ahead, watch again and then understand the problem. Relation R. Okay. So relation R is having 1, 2, 3. 1, 1, 2, 3 and set is, sorry, not relation R. This is a set, means where the relation is defined. Let's say set A is having the relation where the relation is defined 1, 2, 3. Set A is this. Now relation R is defined on set A. Okay. Where relation is given as, the relation is given by 1, 1. Okay. This is a given relation. So we have to check whether reflexive, transitive or not. So let's do it. First way, reflexive, symmetric and transitive. Okay, sir. Reflexive, no, bacha, because if 1, 1 is there, 2, 2 has to be there, 3, 3 has to be there. So 2, 2, 3, 3 is not there. So no. Okay. What about symmetric? If 1, 1 is there, symmetric was what? ARB, then BRA has to be true. So ARB is there, BRA is not there. Correct now, because 1, 1, 1, 1 will make the same thing. So symmetric, yes sir. Symmetric, yes sir. What about transitive? We can't even check because what is it there? So ARB, BRC, ARB, BRC. Then ARC has to be there. We can't check. So we can't call it. Okay. Then it will be simply transitive. I said no, only if you check. When will you check whether it is transitive or not? If this condition is there. If 1, 1 is there, it can be kept as it is. No, 1, 1, 1, 1, 1, 1. Think about it. Are 1, 1, 1, 1. What is the result? 1, 1 only. No. So 1, 1 is there only. We don't write the repetitive elements. You know, while writing the set, we don't repeat the elements. Do we? I hope you know that. While writing the set, we don't repeat. Will I write this as one set? We can't. We will write only one. We will write only one, bacha. Only one. So it's there, no? 1, 1 is there. It means transitive also is true. Transitive also is true. I repeat. We can't check this condition ARB, BRC, ARC because the difference in the A, B, B, C does not exist. But this 1, 1 will validate. I said no. Whenever you have AA, don't check. Whenever you have AA, AB, don't check. Okay, like this. Don't check. Okay, don't check. So these are the conditions. Don't check. I have taught this in detail. Please go and watch the video. Okay. Answer is what, sir? Symmetric and transitive. Option B, symmetric and transitive. Okay. We can move on now, bacha. Let's move on, sir. Okay, question number 4. Okay, let A is given, x is real number, x is not positive integer. Okay, and set A is defined means basically they are saying that not positive, right? So it can be 0 or negative integer. Okay sir, and relation is like this, a to r, a to r. Okay, what is this? R is the real number, correct? R is the real number. Function is defined on this. So both of these are real numbers only. Okay, fx is defined as give me a second. Okay, so we have to solve it here only. So fx is defined as 2x upon x minus 1. 2x upon x minus 1. Now we have to check whether injective or surjective or not. Whether to check injective or surjective or not, sir. Okay, can it be injective? So how will you check injective? 1 1. How will I check 1 1? So if I take let's say f of x1, or basically if you want I can take f of a also. Some variable I can take it as a also, na? Some value I can take, na bacha. Let me take it as f of a. If I take f of a equals to f of b, f of a equals to f of b, then what should be? For it to be 1 1, I should get a final result as a equal to b. Correct, na? For it to be 1 1 or injective, f of a, if this is my if condition, if f of a equals to f of b, then a has to be equal to b. Okay, let's check here. What will this be? 2a upon a minus 1 equals to 2b upon b minus 1. 2 goes out. What I get? Let's cross multiply. I get a times of b minus 1. A times of b minus 1 equals to b times of a minus 1. Let's see here. What I get here? ab minus a equals to ab minus b. Correct, na bacha? ab cancels out, right? ab cancels out. What I have left here? Minus a equals to minus b. Check here please. Minus a equal to minus b, which means what, bacha? Which means a equal to b. Correct? A equals to b. So what I'm getting here, let me erase it this part. I started from fa equal to fb and reaching a equals to b. It means it is 1 1. What is it? It's 1 1 or injective. What about onto? Let's check here. What about onto? So onto other name is surjective. I told you, remember both the names. Okay, onto other name is surjective. Let's check for onto. So I can take this as y equal to 2x upon x minus 1. Okay, x minus 1. Replace this. I can write this as what I can write this as? Y times of x minus 1 equals to 2x, right? 2x. I'm trying to make x is my subject. Okay, then I'll get a value for y where it is, like a boundary condition will exist. Okay, so I'm writing the subject change. Okay, so this will become yx minus y equals to 2x. Correct na? So bring this y over here and this 2x over here. So I get it as yx minus 2x equals to just y. Okay, take x common, bacha. So will be y minus 2 equal to y. What I get here? Okay, x equals to y upon y minus 2. Correct. Now what is this condition giving us? This condition giving us y cannot be equal to 2. But look at here. Here very carefully. What is this? A is non-negative. Non-positive. But r, what is my? This is my, what do you call? This is my x, right? This is my y, no? Correct, right? Domain to codomain or domain to range. So y has to be real number. Is 2 not a real number? It is a real number. Then why 2 is not part of the answer? I told you, check wherever it is not true. Okay, don't check for wherever it's true. Then that will be a lot of data points. So check where it is not true. So I'm getting a value y which is not equal to 2, which should have been the answer, because y is a real number. Then it means it is not onto. I took x, I can take x as x as a positive number, but I'm getting y as a number which is actually a real number, but it is not coming as the solution. It means it is not onto. So I can say here, onto nahi hai. So what is my option? Option A, sir. Okay, I know this got a little lengthy, but some questions might. Okay, not all questions will be very easy to solve. Some will be difficult. A set, A is a set having 6 digits. I have moved on to the next question. I hope you understood this. Previous one. A is a set of having 6 digits. 6 distinct elements means A. What is NA? NA is 6 bacha, NA is 6, that's what is written. A number or relation from A to A means relation is defined A to A, okay, relation defined A to A, A to A, okay sir. Not bijections, not means what is the number of bijection here? How will I write number of bijections? Can you write here number of bijections? I can write sir, why? Because NA is same, no? So 6 factorial. 6 factorial, right? Number of bijections 6 factorial. What is the total number of function? So total number of function was n power m. But in this case, n and m are both same, no? Because it's on the same set, A to A. So I can write this as 6 power 6. The total number of function is this. And total number of bijection is 6 factorial. Means what are the function which is not bijection? I'll repeat. Total number of bijection 6 factorial. Total number of function 6 power 6. Then what are the function which is not bijection? So from the total, subtract the bijections. Correct? We are looking for a function which is not a bijection. So total will be no bijection. We are looking for okay, not bijections. Function which are not bijections. Then this will be what bacha? 6 power 6 minus 6 factorial. Is this the answer? Check please. C. Correct, no? Correct, right? Move on. Please move on. Okay. Question number 6. FR to R. FR to R is defined as this. Array. Okay, this is a simple question, right? Because only positive will come. So answer would be what? We have to check 1 1 and on 2. 1 1 and on 2. Can we check 1 1 on 2? Let's check 1 1 first. Fx equals to x power 4. Let's check 1 1. Sir, if I take x equals to minus 1 and x equals to plus 1, what is the answer? So f of minus 1 is equal to f of 1, which is equal to 1. Because minus 1 power 4 is 1 and 1 power 4 is 1. So f of minus 1 is equal to f of 1. But is minus 1 equal to 1? No sir. That's how we check, right? F of minus 1 equal to f of 1. But minus 1 is not equal to 1, means not 1 1. Not 1 1. You can write here. By not 1 1 sir. Okay. What about onto? What about onto? That we can directly say from here. Check here. Only positive outcomes. Correct? But defined on real. Defined on real. So not onto also. Not onto. Okay. The limitation is there. No. Limitation is there. So which is the answer? C. Oh, B is the answer. B is the answer. Neither 1 1 nor onto. Means neither of the case. Okay. Let's move on sir. Let's move on sir. I hope you understood. Only positive. X power 4 has to be positive, right? Okay. Square of something. Always positive. Now previous one we have done. Let's move on to the 7th one. A set A has 4 elements. Forgive me. A set A has 4 elements. A set A has 4 elements and set B has 5 elements. Okay, okay sir. So basically they are saying that n of A is 4 and n of B is 5. N of B is 5. Then the number of injective mapping. Okay, this is so simple, na? Number of injections. Number of injections, okay, was given by, if I take this as my M and this as my N, okay, then this was what? MPN, okay, whatever it is. Just the 5 will come here, 5P4, which is nothing but 5 factorial upon 5 minus 4 factorial, bacha. So I can write this as 5 into 4 into 3 into 2. Niche, so we have only one. We have only one. So 5 into 4. How much is that? 20. 20 into 3, 60. 60 into 2, 120. Answer is 120. D. 120. 120. Correct? 120, na? 5 into 4 is 20. 20 into 3 is 60. 60 into 2 is 120. Let's move on, sir. 8th problem. FR to R. FR to R be defined as reciprocal function 1 upon x. Okay, sir. Y equal to what, bacha? 1 upon x. Defined where? On all real numbers. On all real numbers. Okay. Check whether it is on 2 not defined 1 1. So simply not defined. Sir, how, sir? If I take x equals to 0, what happens to y? Y, or what is y? Basically fx. Fx or y, whatever you want to call. When x is 0, fx or y, whatever you want to call, not defined, na sir. Not defined, na sir. Because it will approach infinity. So if fx or y is not defined over what? What is x? Is x a real number? X is 0. but y is the what, infinity. This has to be real, and y also has to be, check here, this is my y, this is my x. X is real, y has to be also real. Is it real? No sir. Is it real? No sir. It means not defined, bacha. It means not defined. Answer is what? Not defined. Answer is what? Not defined. Simple question. X is 0, you put here, it's not defined. Okay. Let us move on, sir. Let us move on, sir. Okay. S be the set of all real numbers. Okay. A relation has a relation R has been defined on S using this. Okay. So basically relation is given by A minus B, the difference mod is less than 1. Means if you take two elements A R B, which is it? A R B, two elements A B, okay, then A minus B, the difference of the element will be whether it is negative or positive doesn't matter, only the modulus part will be less than 1. Okay. So what we are looking for? Symmetric, transitive and reflexive. So what is the first thing we do? Right, reflexive, symmetric and transitive, bacha. Okay. Reflexive means ARA, okay, ARA. ARA. So ARA will be valid. Why? Because if I do this here, A minus A is what? Is equal to 0, which is less than 1. So reflexive to hai. Correct, right? ARA means A minus B will become A, so A minus A is less than 1. Correct. Let's talk about symmetric. So if, what is this? ARB is true, then what happens? BRA has to be true. Okay. Obviously, no. If A minus B, if this is my if condition, if A minus B is less than 1, okay, then obviously B minus A will be less than 1 only, no? Take an example, 1 minus 2 less than 1, then 2 minus 1 also less than 1. Check. 1 minus 2 less than 1. Check here, please check here. Okay. 1 minus 2 is less than 1. Correct? Correct, na? What is this? Less than or equal to 1. 1 minus 2 is how much, bacha? It's minus 1 the mod, which is less than 1. Correct, na? 1 is less than or equal to 1, which is the condition here. So 1 equal to 1. Correct, right? Correct, right? Okay, this condition is valid. So ARB is valid. ARB is true. Then what about BRA? BRA will be looking like this. 2 minus 1 the mod. How much is that? 1 only, right? Which is again, condition is satisfied. 1 is less than equal to 1. So again, equal to condition will be valid here. Correct, right? So symmetric be here. Symmetric, correct. Symmetric also is valid. Both these are valid. What about transitive? Let's check your transitive. So for transitive, what we can do? Let's take 1, 2, 3. Let's take 1, 2, 3. Okay. For 1, 2, if I'm writing, okay, forgive me. If I'm writing 1 R2, what is it? 1 minus 2 is equal to what? 1 only. So it is valid. 1 R2 is valid. 1 is less than or equal to 1. What about 2 R3? 2 R3 is also what valid? Check here. 2 minus 3 mod, which is nothing but 1 only. That's right. Okay. What about next? What will be what? 1 2 2 3 means 1 3. So 1 R3. How will this look like, bacha? 1 R3 will be 1 minus 3. How much that will be? 2. So not equal, right? Means transitive to nahi hoga. Transitive not possible. Transitive not possible. Transitive not possible, sir. So only R and S. So only RS and reflexive, symmetric, yes, but not transitive. So option C. Okay, correct. I hope you understood it. Moving on. Okay. Now look at this question. Okay, so this is f natural number. F function is defined on natural number. When it is odd, when n is odd, it is n plus 1 by 2. When n is even, it is n by 2. Okay, means the function is defined as such. Whenever we are taking the odd natural number, for odd natural number it is n plus 1 by 2. For even natural number it is n by 2. Okay, so let's check this. First we're doing for 1 1. Let's check for 1 1. Right, 1 1 on 2 we are looking for. We're going to find 1 1 on 2. So let's check for 1 1 first. So let's check the value when n is equal to 1 and n is equal to 2. Okay, so basically what will be f1? F1 will be what, bacha? We'll use this formula. So n plus 1 by 2. So 1 plus 1 by 2. So basically what? 2 by 2. So 1. What about here? F of 2 will be just 2 by 2. So just 1. So what we are getting? F of 1 equal to f of 2. But 1 is not equal to 2. So what? What is the answer? Not 1 1. Not 1 1. What about onto? What about onto? Check here. What about onto? For onto, what is the function given? The function is given as y equals to n plus 1 by 2, one of these. Another function is what? This is when it is odd, and for even it is given as y equals to just n by 2. Okay, let's check here. If I solve for n, what I get? So basically we are interchanging the domain and range part. So what we're gonna get, subject will changing. So 2y n plus 1. Now check here, n equals to 2y minus 1. Now see, I took n, if n is natural, this will also be natural number. Correct, right? It will be natural number. So I get both of these are natural numbers. Correct, correct. So I have taken, if y is natural number, think about it. What is the condition? I have taken here y is natural number. Okay, okay. So no confusion. Let me just write it here. Y is natural number. Then what will be n? N will also be natural number. Correct, right? Correct, right? Because 2 times of natural number, some number will come in, and minus 1 will again be natural number. So this is true. Means for this I am getting the same result. Y natural, n natural, where the function is defined. What about this? If y is natural, then I can get this as 2y equals to n. Now see here, if y is natural number, then again n will be what? Natural number. So both the conditions are valid. So for both the functions, where odd or even, this has to be what? Natural number. So I took this as y. I took this as y. So when I took y as natural number, I got n also as natural number. It means this function is validated. So I get what? Option A. I get what? Option A. On to but not 1 1. On to but not 1 1. Moving on. Moving on. Okay. 11th problem. The number of bijective functions from set A to itself. Or this is so simple. Set A is having n. Sorry. Forgive me. N of A, right? N of A is 97. They are asking us what? Bijections. So n factorial only. How much is that? 97 factorial. How much is that? Option C. Simple question. Let's move on. Let's move on. Okay. Now this problem. They are saying let there's a set given as ONGC, BHEL, SAIL, GALE, IOCL. Okay. So 2, 3, 4, 5 elements, right? 1, 2, 3, 4, 5 elements. Okay, they are not asking that, sir. Okay, fine. Number are not asking. A relation is reflexive and transitive or not. Okay, okay, okay. Okay. So we have to see that. We have to see that. Okay, what is the relation? The relation has to be understood, no? The relation is what? They share exactly one letter. This is the relation, bacha. They share means the words which is written here, ONGC, BHEL, SAIL, GALE, IOCL, they should share exactly one letter. What does the letter means? The alphabet has to be only one common. So if you look at here, for BHEL and SAIL, okay. So if I'm writing the relation R, if I'm writing my relation R, how will that look like? Check here, I'll write from here. So my first will be what? I can go BHEL and SAIL. Why, sir? Only one is common, L and L. Correct? BHEL and SAIL. Only L is common, so I can write BHEL and SAIL. So BHEL and SAIL. Okay, sir. Next element will be what, bacha? Same thing. BHEL and GALE. Again, only L is common, right? And BHEL and IOCL. Also, again, L is common. So I can write that also. So BHEL, comma GAIL, BHEL and GALE. Okay, next will be what, bacha? So again, BHEL and what? IOCL. Okay, again only L is common, right? And only L is common. Check here, please check. Now last one is what? Last one is what, bacha? BHEL with SAIL, GALE is done. Now I can go ONGC with IOCL. ONGC with IOCL. So ONGC with IOCL. This is my another element. So 4 I've got. Okay. Now I can, but I can also write in the opposite way. Correct, na? Correct, right? Because I can write SAIL first. So if I have to do that, I can do like this: SAIL, comma BHEL. This will also be the element in R, because again they have only one common, SAIL and BHEL. Okay, this is I. Then I can again go this way. This is my GALE, comma BHEL. Check here again. So GAIL and BHEL will also have only one common. What next? For this also we can do IOCL coming first. IOCL coming first. Okay. With what, bacha? With BHEL. With BHEL. Okay. So now last one is IOCL with ONGC. Last one is IOCL with ONGC. If this is confusing, understand it like this. If ARB is having only one letter common, then obviously BRA will also have only one letter common, na? So from here we can say directly symmetric is there, sir. So symmetric is there, sir. Okay? Because if ARB is having only one letter common, then BRA also having same letter, only one letter common. So symmetric to hai. Symmetric is there. Let's check. So symmetric and transitive. So this we got right. This we got right. Okay, sir. What about reflexive, sir? What about reflexive, sir? Reflexive will look like what, bacha? So ARA. If I write like this, let's say, let me write it like this. So the element will look like Bale, comma, Bale. Correct, right? Bale, comma, Bale. How many letters they have common? Sir, 4. But what are they asking the relation? Only one common, exactly one. So reflexive can't possible, because if you write the element with itself, then 4 common will be there. So not possible, sir. What about transitive? What about transitive? Okay. Now over here, just have a look. If I take this, let's say I take these two elements. Okay. Let me take these two elements. This and this. This and this. Okay. So what I'm taking? BHEL. What is the property? ARB, BRC. Then what is the condition? ARC has to be true. This is transitive, right? This is for transitive, right? Okay. Then what is my element? Bale, comma, sail. Just look at this. And what is the next one? Sail, comma, bale, right? This is my ARB. This is my BRC. Then if you combine this, what will get? You will get BHEL, comma, BHEL, right? How many elements are common? 4. How many elements are common? 4 elements are common. Means again, transitive, not possible. Transitive, not possible. So transitive also is not gonna work. Okay? Not gonna work. So only symmetric, option C. Option C, only symmetric. I hope you understood this. Okay. Now question 13. Question 13. This is it. Okay, this is it. Okay, let's do it. Let A be the set of all animals. ARB. Okay. So ARB. What is the relation R? Relation R is indifferent Jew. Means the animal A and animal B are in different Jews. So are in different zoological park, basically called as zoo, right? Or parks, whatever it is. So sanctuary or whatever it is, but they are the elements A and B. So let's say element A is tiger and element B is, let's say, snake. Then they are at 2 different places. Means if I have 2 sanctuary here, so let's say I have element A as, okay, I have element A as elephant, let's say. So elephant is over here. Then what I have a, let's say in park B I have I have a crocodile. So elephant is in one zoological park and crocodile is in another zoological park. Whatever are the reason, okay, maybe more habitable for crocodile there and an elephant can stay here, right? So whatever is the reason, but they are staying at 2 different zoological park. So this is the relation. So A and B are in 2 different zoological park. Now think about it. So we are looking to get our answer for what, bacha? This reflexive, symmetric and transitive. ARA. Is it possible? Can A and A be in different zoological park? Can elephant and elephant be in different zoological park? No, sir. Because they are saying no. If A is already there in park, let's say elephant is there in park A, then how can elephant be there in park B? It's not there. It has to be in A only. The reflexive not possible. Reflexive not possible, right? Not possible, no? Why not possible? Because ARA. If A is in A, then how can A be in other places? Can you be at 2 different places? No, sir. It cannot be at 2 different places. So ARA is not true. What about symmetric? What about symmetric? So symmetric will be like this. So ARB and BRA. If A is here, B is in a different zoological park, then obviously B is in different zoological park. So if A and B are in different zoological park, then B and A are also in different zoological park. So symmetric is there. Symmetric, yes. Symmetric, yes, sir. What about transitive? What about transitive? Check here. Check here. So if I write here transitive as ARB, means A and B are in different zoological park. Okay. So A is here, B is here. Okay. Now I'm writing here BRC, let's say BRC. So BRC I can write. So B is here, C is somewhere here. Okay. Now what if this C is actually over here? I can, let's say I have a condition where this C is over here. I have let's say an animal where C is in the first park only. If this is my park 1 and this is my park 2, okay, this is my park 1 and park 2. A was in park 1, B was in park 2. Now second case, when B is in park 1, sorry, B is in park 2 and C is in park 1, is it valid? Yes sir, it's valid. Why is it valid sir? Because they are in different park only. No, the condition, the relation is only saying that different geological park. So even this is true. This is A and B in different park, B and C in different park. But is A and C in different park? No sir. Means for this particular situation, it cannot be transitive. And we have to look for every situation. So if it is not transitive in any case, it means it is not transitive. It is not transitive. Answer is only symmetric. Answer is only symmetric. I hope you understood. It has to be true, transitive for all the cases. But in this particular case, where A and B are in different park in the park 1 and 2, and B and C are in different park in the park 1 and 2 again, then A and C has to be in different park, but A and C are in the same park 1. It means it cannot be the case. If you want, you can write like this also. A are B, B are A, then what has to be there? A are A, which is not possible. You take it as A are B, B are A, or A are B, B are C. Both of the conditions will be giving you not transitive. Not transitive. I hope you understand this. Let's move on to the next question. 14. Let A be set of compartments in a train. Okay, the bogies. Okay, compartment like this. Okay. Then the relation R is defined as A and B have the link between them. Means the link which is joining the two compartment, that is there between them. Okay, sir. Check whether it is reflexive or not. So reflexive, symmetric, transitive. Okay. Okay. Can a compartment have the link with itself? Can it have the link with itself? No, sir. It will join with some other compartment. No. How will it join with itself? So reflexive, not possible. It cannot. Any compartment cannot join with itself. If you keep it with itself, will it be balanced or aligned? Not possible, sir. How can you join something with itself? Not possible, sir. In the compartment size. So X is means reflexive, not possible. What about symmetric? Okay, so if this is my A, this is my B. A is linked with B, then B is also linked with A, correct? Symmetric, yes. Look at this compartments, A and B. A linked with B, B linked with A. So yes, symmetric. What about transitive? Add here. C. A linked with B, B linked with C. Is A linked with C? No, sir. Direct link is not there. No, direct link is not there. So A is with B, B is with C, but A is not with C. So only symmetric. B, only symmetric. I hope you understood this. Question number 15. Question number 15. Okay, sir. If a set A has 13 elements, R is reflexive relation. Okay, okay, okay. So set A, NA is what, bacha? 13. NA is 13. Okay, sir. That's what they've given. Now they're saying relation R is defined like this. A cross A means A to A. Okay, basically if you want to write it as A cross A, that also is true, or A to L C if you want to write, that also is correct way of writing the relation. Relation is defined on A to A. Relation on A only. Okay. Then N will be between what? This number N will be between what and what? Okay. So basically how many such relation is possible? Okay. Reflexive relations is possible. Okay. Okay. So now think here. So if I am making the relation, what is the meaning of reflexive relation? Reflexive relation. AR has to be true. ARA has to be true. ARA has to be true. If I am writing ARA, I can write, let's say, the elements are what? 1, 2, 3, 4, 5. Okay. Or ABC, whatever it is. Okay. So first will come with itself. So first element A will come with A. That's also reflexive. Second will be what, bacha? B with B, C with C, and so on till what? 13 terms. Correct, right? This will be my relation. So minimum this has to be true. Think about it. For the relation R to be reflexive, for the relation R to be reflexive relation, a minimum of all these 13 elements should come. If let's say I don't write C, B cross B, is it reflexive? No, sir. All the element has to be true. Remember this condition, 1, 2, 3. If I write just 1, 1 and 3, 3, is it reflexive, sir? Not reflexive, sir. 2 and 2 is missing. So all the 13 element has to come, correct? So minimum number of elements, okay, has to be what, bacha? Has to be what? has to be what? 13. I hope you understand this. So this n, okay, will be what? Will be at least bigger than number of a. So this is what? Number of what? R. Okay, n is the elements in the relation R. I hope you understand this. A relation R with n elements, correct na? With n elements. So n represents elements in relation R. So n of R has to be at least a minimum of what? N of A, which is how much? 13. Which is how much? 13. So this part is clear. What about maximum? How much it can have maximum? A cross A will have how many elements total? Think. So I can have A, first one. I'm writing about maximum. I'm writing for maximum. Okay, there's not enough space. Let me write it over here in the next slide. Okay. So I'm writing for the maximum condition. Okay. So the relation R can look like this. What? Element A with how many elements? 13 elements. Not 13. It's not the number 13. Is it 13 elements? With 13 elements. How, sir? So A can be with A can be with B, A can be with C, A can be with... So if I have to show you, A with A is true, A with B is true, A with C is true till 13 elements. Why, sir? What is the definition of reflexive? A and A has to be there, extra is okay. Correct? So A and A is there, extra is okay. So all maximum possibilities has to be there. So the first element the A can combine with how many elements? 13 elements. Same way, B can combine with 13 elements again. Again, C can combine with 13 elements again. Right? And so it will keep going on like this. So I have 13 elements like this, 13 over here, 13 over here. And how many I have? I have 13 such terms. 13 such. Okay. So I get total what? I get total as 13 plus. This will be 13 elements. A with A is 1, A with B is 1, and we'll go to 13. So it means this is A with C. Okay, and we'll go with 13 terms over here also. Right or not? This is just for this part. Okay, same 13 will come for this and this and this, still 13 terms. So 13 plus 13, how many times? 13 times. What I get? 13 into 13. How much is that? 169. Okay. So what is this? This is n of A cross A only, because this is all relation. So I can write this as n of A cross A. How much was this? This was 13, and this was n of R less than equal to what? 169. Is the option correct? Option C, option correct. I hope you understood this. Okay, sir. We did the previous one? Yes, sir. Okay, let's move on to the question number 16. Let X be the set of all engineering colleges in state of Indian Republic. Okay, sir. All engineering colleges, okay, in state of Indian Republic, okay. And R, what is the relation R? What's the relation R? Most important part. Read this. R is a relation on the set X defined as two colleges. Two colleges are related if they are in same university. If they are in same university, means if the colleges are in same university, then we can say the relation is valid. So what is the relation? Colleges, okay, in same university. Same university, sir. Same university. This is the relation. Same university, sir. Okay. Not readable. Just understand the meaning of it. College in same university. College in same university. Okay, sir. The relation is defined now. The relation is defined now. Okay. 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 Yes, sir. Now check whether it is symmetric, reflexive or not. So first thing what we do. Reflexive, symmetric and transitive. Now check here. For reflexive, what's the condition? College A with college A, correct? If college A is in same university, then obviously college A is in same university, no? Let's say I can take a college which is, let's call, I don't know, some X college is there in VTU, okay? Then obviously this college is there in VTU, so it is reflexive, no? Itself will be valid. A to A will be valid, right? So reflexive is there. Okay, what about symmetric? Think about it. College A is in the university as B, then obviously B is there in the same university, no? A and B in same university. Then B and A is also same university. So symmetric is also true. Now transitive. Transitive you check here. A or B, same university. Same university. What about this? B or C, again what? Same university. Then what about A or C? A and B same university, B and C same university, means all of these three are same university only, no? Same university only, right? So basically A, B, C are in same university, right? Means even it is transitive, A and B in same university, B or C is in same university, then AC will be same university, so sir transitive also. If a function is, sorry, if a relation is RST, we call it as equivalence relation, sir. Equivalence relation, sir. So option D is correct. Moving on. 17th question. A signum function, okay, defined on real numbers, okay, defined like this. We know the signum function definition. What's the definition of signum function? Okay, all real numbers will take x, y. This is my x dash, this is my y dash. How does it look like, sir? How does it look like, sir? So it looks like this, bacha. I hope you remember. So this is open here, close here, and open here. Okay, this is my -1, 0, 1. Okay, means for all positive real numbers, answer is 1. For all negative real numbers, answer is -1, and for 0 it is 0. Check here. For all positive real numbers, it's 1. For all negative, it's -1. For 0, it is 0. For 0, it is 0. Okay, sir. Now check. Can it be 1, 1? Sorry. Can it be 1, 1, sir? It cannot be 1, 1, no, because for this value, same formula. All these values will have same answer as 1, right? So if you take f of any positive number, f of 1, what's the answer? 1. F of 10, what's the answer? 1. So f of 1 equal to f of 10, but 1 is not equal to 10, na? Correct, right? So not 1, 1. What is the answer? Not 1, 1. Not 1, 1. Okay, what about onto? Sir, the domain was what? What was the codomain? All real numbers. But it's limited over here. What is the answer? Only 0, 1 and -1. Only this is my range. This is my range. So range is not equal to codomain, sir. Codomain, sir. So what is the answer? Not onto. Not onto. So neither 1, 1 nor onto. What is the answer? C. What is the answer? C. Check here. Yeah, it's many one. Okay, so it's many one. Correct. The option is not given as not 1, 1, 1, 2. So 1, 1 bhi nahi hai. 1, 1 is not there. 1, 2 is not there. Many one it can be. Why many one, sir? Because if you draw the line overlapping this, it is intersecting the graph at multiple points. So many one, no? Many one, right? This condition also is valid for many one. F1 is 1, F10 is 1, whereas 1 is not equal to 10. So what is it? Not 1, 1 means many one, sir. Means, yes, let me write it again. Not 1, 1 means what, bacha? What, bacha? It means many one, na? Not 1, 1 means many one. So answer is what? Many one. Answer is many one. Okay, let's move on. Okay. 18th problem. Let function defined as n to n. Let function defined as n to n. Okay. Fx is given by this. Okay. For all natural numbers. For all natural numbers, obviously. Then f is. Okay, sir. Okay, sir. Let's check. So I'll write it as y equals to x square plus x plus 1. Next slide. Y equals to x square plus x plus 1. I'm writing y as fx. Okay. I'm writing this fx as y. No problem. Defined on what, bacha? Defined on a natural number. Means domain is also natural, range is also natural. Okay. So this is a natural number. Both domain and codomain is natural number, or range is natural number. Okay, sir. Y equals to fx I've taken as y equals to x square plus x plus 1. Okay. Check 1, 1 or on 2 hai ya nahi. Okay. So for 1, 1, first for we are checking for 1, 1. Let's take two elements a and b, which is natural number. Which is what? Natural number. So I've taken two numbers a and b, which is natural number. I can take, no, not a problem. I can take any number as natural number. Put it here. I'm taking f of a equals to f of b. F of a equals to f of b. I hope you understand this. I'm taking f of a equals to f of b. After taking this, if my a and b are equal, it means what? It means it is a 1, 1 function. Correct? Correct. Okay, sir. Let's check here. F of a will become what, bacha? A square plus a plus 1. F of b will be what, bacha? B square plus b plus 1. Okay sir, cancel this. Okay sir, bring b square here and bring everything here. So I'll get a square minus b square plus a minus b equal to 0, correct? Check here, b square will become negative, b will become negative. Okay, so now take this expansion, a minus b, a plus b. What is common here? Just take here one common, so a minus b. A minus b is common between the two terms, so take a minus b common. Okay, now what I left here, a plus b and plus 1 equal to 0. Now check here, please check here, very important. A is a natural number, a is a natural number, can it be negative? No sir. B is a natural number, can it be negative? No sir. Not even 0, so not negative, not 0, only positive numbers. 1 is also just positive number. It means this entire thing has to be greater than or equal to 0. It cannot be equal to 0, right? This part cannot be equal to 0 because a and b are positive numbers, a is also positive numbers. When some of the numbers will be positive, which is not equal to 0, so this is not equal to 0. This part a plus b plus 1 is not equal to 0. This is not equal to 0. It means what? This has to be equal to 0. A minus b has to be equal to 0. Why sir? Because the product of two numbers is 0. This part cannot be 0. Then this part has to be 0. Think here. Product of two numbers is 0. This part cannot be 0 because it is a positive number. Then this part has to be 0. Now if you solve this, what you get? A equal to b. A equal to b. You started here with fa equals to fb. We are getting here a equal to b means what is the function? The function is simply 1 1. The function here is 1 1 1 1. What about onto? What about onto? Okay. What about onto? Let's check. Now we're going to check for onto. We know the function is defined where, bacha? Natural number to natural number. Means if I take x or y as natural number, if I take any natural number for y and for x, basically if I take for y as natural number, x should also come as natural number. Correct, right? Means I am taking y as some natural number. Then x should come also as natural number. Let me take y equal to 4. Can I take y equal to 4? I can take y equal to 4. So let's take y equal to 4. Correct? It's a natural number, no? Is it a natural number? Yes, sir. I'm taking y equal to 4. Put it here. 4 equals to x square plus x plus 1. Correct? Bring that 4 there. It becomes 0 equals to x square plus x minus 3. Correct? This is my quadratic equation. How will you solve this? Use the formula. So minus 1 plus minus root under b square will be what? 1. Minus 4ac will become what? Plus 12. 4 into minus c will be plus 12, no? By 2. Answer is what? Minus 1 plus minus root 13 by 2. So what we can say from here? X is not natural number. Is x natural number? Check here. It's a fraction. It's not even rational actually. Root 13 is not rational. So how it is natural number? X is not natural. So I took y as natural and I got x as not natural. Okay, not natural. It means the function is not onto. Because if x is natural, y has to be natural. Correct, right? Because what? Domain has to be, like codomain has to be same as the range, no? Okay. So means not true, so not onto. What's the condition? What's the condition? What's the condition? Not onto, sir. So we have 1 1 but not onto. Check here. Check the option. C. 1 1 but not onto. 1 1 is there but not onto. Okay. Moving on to the next problem. Which of the following is bijective function on the set of real numbers? Alright. Know the graphs. Bijective means what? Bijective means what? 1 1 and onto. 1 1 and onto. Okay. So first one, option A. Check here. Straight line, right? Straight line. No, option A is a straight line. How will it look like? When x is 0, y is minus 5. Somewhere here. When y is 0, x is 5 by 2. So somewhere here. A straight line is 1 1 onto, no? Is 1 1 onto, right? So option A has to be correct. Option A has to be correct. Directly we can write here. Anyway, a straight line is always 1 1 onto function, right? Now, this is what point? 0, 5. So 0, minus 5. This is what point? 5 by 2, 0. 5 by 2, 0. Okay. It's a straight line. What about mod of x? How does mod of x look like? Remember, if you want to know all the part, mod of x is this. If I draw a line, 2 points of intersection. 2 points of intersection means not 1 1. Other function, quadratic, x square. Quadratic function will be what? Again, you'll have 2 points, go like this or this, 2 point of intersection, x square plus 1, again quadratic only. So option A is correct. Option A is correct, sir. Option A is correct. I hope understood. Option A is correct. No, this is correct, sir. Okay. Okay. Now, moving on to 20th problem. Which of the following function is not 1, 1? Not 1, 1. Means we have to look for what? The graph where it is cutting more than one time. This is the 1, 1. I said don't have to check for linear functions. This is linear, means it's a function of a straight line. Y equal to 6x minus 1. It's a 1, 1 function. Don't have to check. Now, if you know quadratic, okay, then this will be a simply quadratic equation. So, if you don't want to check everything, if you have this same question in the exam, you look at this and you'll say this is not 1, 1, because quadratic function, no. If the graph is like this, cuts at 2 point, so not 1, 1, not 1, 1, okay, not 1, 1. So I can directly write it as option is B, option is B, option is B. But if you want to know the graph of x cube, okay, if you're looking for graph of x cube, the graph looks like this, right? Okay, so it will be 1, 1, okay. What about this? Without drawing graph, we can solve this question. Take some value, no, 2x1 plus 1 upon x2 not x2. Let me take this as a and b only, makes our work easier. Why write it as x1 and x2? So 2a plus 1 upon a minus 7 equals to 2b plus 1 upon b minus 7. What I'm doing, I'm taking f of a as equal to f of b. F of a equals to f of b. I can take all real numbers except for 7. I've taken number which is not equal to 7, obviously. So if I simplify this, what I get? 2a plus 1 times b minus 7 and 2b plus 1 times a minus 7. If you expand it, ultimately you'll get this. You'll get a equal to b. Means what will happen? I'm saying that solve it. Solve these steps. Okay, if you do that, you'll get this as also 1, 1. This is also 1, 1. Okay. So only in this condition, what is the answer? Quadratic of this order is always 1, 1. Okay, is always 1, 1, sir. Okay, moving on to the next question. What is it? Let g equals to, there's a function defined like this, r minus 1, 1, means this is not part of the answer. Okay, this is not a small bracket, this is like this, means minus 1 and 1 is not part of the answer. Okay, of the what? Of the domain, and this is my range, right? So domain is exclusive of minus 1 and 1, range is just r. Okay, now the function is given as gx equals to 1 upon x square minus 1, 1 upon x square minus 1. We have to check both, whether it is 1, 1 or not, or on 2 also we have to check. Both the properties 1, 1 and on 2 we have to check. So how will you do this? Let's see here. So function is given as, am I right? Let's cross check. Correct, sir. Okay, so what we're doing? Let's check for 1, 1. Whether it is 1, 1 or not. So how will I check, sir? I can take two values. Take two values a and b, and say that fa equals to fb. This is my assumption. Fa equals to fb. If I assume this, for this function to be 1, 1, then I should get at last what? A equals to b. Correct? Let's check if it's coming like that or not. 1 upon x will become what? A. X will become a, sir. So this will be a square minus 1 equals to 1 upon b square minus 1. Correct? Cross multiply, you get b square minus 1 equals to a square minus 1. Right? This is cancelled. Now what do you get? You get a square equals to b square. So a equals to plus minus b. Again, is it coming as a equal to b? No, sir, it's not coming as a equal to b. Means not 1, 1. Correct, no? It has to be only a equal to b, not minus b. Okay, so both conditions are coming here, because if you take root, plus minus sign will come. So not 1, 1. Check here. Not 1, 1. First part is done. Okay, not 1, 1. What about on 2? Let's check for on 2. Just give me 1 second. Okay, let's check for onto, bacha. So if I check for onto, how will this look like? How will this look like? The function, I can assume this function to be y equals to, okay, 1 upon x square minus 1. Now let's check the domain and range. So domain is everything but minus 1 and 1, and ranges are why minus 1 and 1, because if we put minus 1 and 1 as x, no, then what will happen? This denominator will become 0. So we don't want that. So that's why minus 1 and 1 are not part of the answer. So x square minus 1 is there for that reason. But range is what? All real. Range is what? All real numbers. Okay. So if I solve for x, what I'm gonna get? I'll get x square minus 1 equals to 1 upon y. I'm making what? I'm making s as the subject. Okay. So of the formula, x square equals to 1 plus 1 upon y, like this. So I get x square equals to 1 plus y upon y. So I get x equals to 1 plus y upon y under the root. Okay. Now obviously this x will be this value has to be a positive, means we have a constraint, means some not in, if I write real numbers, it has both positive and negative, both positive and negative. Whereas if you look at this, there's restriction given, there's some restriction given, it has to be positive only. Okay, for that reason it cannot be 1 2, it cannot be onto, sir, cannot be. So not onto, what I get? Neither 1 1 nor onto. How, sir? Not 1 1, not onto. So what is my answer? D. Okay, let's move on. Okay, I hope you understood. Now this question, as I said, in this test you've already given, so we'll have 2 parts. ITF is also there, so we have the next few questions on ITF, right? I hope you have solved all of this. So please cross check this, please cross check your answers over here. For every correct answer, award yourself +1. If you missed the question, 0. If you got it wrong, 0. Okay, sir. Okay, sir. So this problem, sine inverse. So sine, to operate sine inverse, bacha, what we need? We need we need sine, na? Means to get this operation successful, to make this sine and sine work, this has to be sine, right? Because sine inverse of sine is what? Just x. So but we have to make what? We have to make this cos into sine. So let's see how we can do that. First of all, this angle has to be between what? For sine inverse, what is the domain? This angle has to be, this value has to be what? This whole thing will be coming in between minus pi by 2 to pi by 2. Correct, sir? That's the range of sine inverse. Sine inverse range is minus pi by 2 to pi by 2. Okay, sir. So let's check. Okay, sir. We'll see. Both of these can be part of the answer. We'll see later. How we convert this cos to sine? We have to convert this cos to sine because sine inverse of sine only can give us answer. So let's go ahead. Writing this as sine inverse of cos of what I can write? Can I write 50 pi by 5 plus 3 pi by 5? Please agree with me. 50 pi plus 3 pi is 53 pi. So that's right. So can I rewrite this 50 pi by 5 as just 10 pi? Because 5 times 10 is 50. So I can write this as just 10 pi. Right, bacha? So just 10 pi. One more thing. We know that cos of 2n pi plus theta is how much? Simply cos theta. Why, sir? Because this angle will come in first quadrant. 2n pi will take some rotations. So n times will take rotation and this angle will come in first quadrant. So for that reason, cos 2n pi plus theta is what? Cos theta. Okay, I hope you understood this. Okay. Alright. This is again, just remember this. Let's move on. So I can rewrite this thing as sine inverse of cos of what? Same thing, 3 pi by 5. 3 pi by 5, correct? Now, as I said, I need to convert this cos into sine. How can I do that? We know that sine and cos are complementary function. So pi by 2 can come into effect here. So cos of pi by 2 minus 3 pi by 5. How, sir? Remember, cos of 1 second. Sorry, not cos, no, sine. Sine here. I wrote cos, forgive me, this has to be sine. Okay, why, sir? Remember this formula. Sine of pi by 2 minus theta is what? cos theta. Same thing. Cos theta is here. This is sine pi by 2 minus theta. I hope you understood. Again, this is the formula here. Let's move on with the step. This will become what? Simply sine inverse of sine will be sine. What will this be? Sine inverse of sine will be just theta. So pi by 2 minus 3 pi by 5. Simplify. What is the answer? I'll get over here is 10. So 2 5s are 10. 2 5s are 10. Okay. Okay. 2 5s are 10 will be, so 5 pi minus 3 pi. How much is that? 2 pi by 10. 2 pi by 10. Okay. So this will look like what? Sine inverse of sine what? Theta. Sine theta. So what will this answer be? Simply theta. Theta is what? Theta is this value, pi by 2 minus 3 pi by 5. Okay. Simplify this. Please take the LCM. LCM is 10. LCM is 10. This will be 5 pi minus 6 pi. How much is it? Minus pi by 10. Minus pi by 10. Answer is D. Answer is D. Answer is D. Okay, let's move on. Okay. This question, 3 tan inverse x plus cot inverse x. This is a very good question actually. 3 tan inverse x plus cot inverse of x equals to pi. This is the given condition. The given condition. Find x value. Find the x value. Okay. Excuse me. Let's solve it from here. So first let's take the assumption over here only. So assumption will be what? Let's take tan inverse of x as A, okay, and cot inverse of x as B. I have taken the assumption, bacha, tan inverse of x as A, cot inverse of x as B. We can assume it. Okay, sir. Let's, if I take the tan on that side, it will become x equals to tan A, and over here it becomes x equals to cot B. Now both of these are x equal to tan A and tan B. It means what? X equals to tan A equal to cot B. Correct? Because tan A equal to x and cot B equal to x. It means x equal to tan A cot B. Okay, now look at here. When can I say that tan A is equal to cot B? When can I say that tan A equal to cot B? Whenever we have angle A and B complementary. Whenever we have angle A and B complementary, it means what? A plus B is pi by 2. A plus B is pi by 2. What is my A value? Check here. My A is tan inverse of x, B is cot inverse of x. So let's write it there. Tan inverse of x plus cot inverse of x equals to pi by 2. Why, sir? A is tan inverse x, B is cot inverse x. Okay, sir. Okay, sir. Now, if you have to look here, I can rewrite this statement as 2 tan inverse of x, okay, plus tan inverse of x, right? I am splitting this 3 tan inverse x as 2 tan inverse of x plus tan inverse of x. Then this part will come here, plus cot inverse of x equals to pi, sir. I hope you understand. Check here. Tan inverse of x plus cot inverse of x, we got it as pi by 2. We got it as pi by 2. So I can replace this by pi by 2. So what I get? 2 tan inverse of x plus pi by 2 equals to pi. Please take this pi by 2 over here. I get 2 tan inverse of x equals to pi minus pi by 2, right? Pi minus pi by 2, which is nothing but simply pi by 2. Okay. This is 2 tan inverse of x. So I get tan inverse of x equal to pi by 4. 2 over here is in multiplication. Will come here, become division. So pi by 4. Okay. When is, so basically this is possible only if x is 1. Because tan inverse of 1 is pi by 4. So answer is what, bacha? Answer is B. Answer is B. Answer is B. Simple question, but you have to use the concept of substitution of x as tan inverse of x as tan A and x as tan A and x as cot B. Okay, moving on. Right? Yes, sir. Okay, here they have given this condition. Sine inverse of x plus sine inverse of y is pi by 2. Find x square value. Find x square value. Okay, again we can do the same thing. We'll take the assumption. Let's take the assumption over here. So they have given that sine inverse of x plus sine inverse of y is equal to pi by 2. That's what they have given. Check here. Yes. Okay. So let's take the assumption first. So sine inverse of x equals to a. I can take sine inverse of x equals to a. So my x is what, bacha? Sine a. Okay. Same way I can take sine inverse of y equal to b. So what is it? My y is sine b. My y is sine b. Okay. My y is sine b. All right. So they are asking us to find what? Find the value of x square. Find the value of x square. So what is they're asking? They're asking us to find this. X square is nothing but sine sine square a. That's what they're asking. They're asking us how much is this value. Now let's go back to the question statement. If I'm writing this as sine inverse of x and sine inverse of y, we know that very sure that the output of any inverse trigonometric function is angle. So basically the angle A plus angle B is how much? Pi by 2. What is it? Angle A plus angle B is what? Pi by 2. Means what? Complementary angles. Complementary angles. Complementary angles. Am I right? Okay. A plus B is pi by 2. Complementary angles. Not readable. I'll rewrite this part. Okay. Rewrite this part. No problem. Complementary angles. Complementary angles. Okay, sir. Okay, sir. Now, if a plus b is pi by 2, it means what? It means sine a equal to cos b. We know this. Sine a equal to cos b. Okay. Now, how will I write cos b? I know sine b is y. So, what will be my cos b? My cos b will be 1 minus sine square b under root. Can you tell this? Identity is there, no? Sine square plus cos square. Okay? Sine square plus cos square. Remember this. Sine square b plus cos square b equal to what? Equal to 1. Equal to 1. So if I'm finding the value of cos square b, this will go here, become negative, and then I have to take root because square is there. So cos b can be written as root under 1 minus sine square b. That's what I wrote here. So I hope you understood this. You know this identity, sine square b plus cos square b is 1. Sine square b plus cos square b is 1. Now what is my sine b value from here? I can put it here. So I get cos b equal to what, bacha? Under the root 1 minus sine square b. So 1 minus y square. 1 minus y square. So what are they saying? It means basically sine a is equal to cos b, which is equal to root under 1 minus y square. How, sir, from here? For complementary angles, sine a and cos b are equal because sine a and cos b are, sine and cos are complementary ratios. Okay. So sine a, let me rewrite this. Sine a is what? Sine a, check here, is x. Sine a is x. So I can write this as x equals to 1 minus y square under root. They are asking us x square, so square it up. X square equals to 1 minus y square. If you square it up, root will cancel. So what is my answer? X square equals to 1 minus y square. Option is A. Option is A. Okay, check here. Let's move on to the next one. 25th question. Okay. Now tan inverse of x plus tan inverse of y they have given as 4 pi by 5. 4 pi by 5. They are asking us to find what? Cot inverse of x and cot inverse of y. Cot inverse of x and cot inverse of y. Okay, sir. Again, what we're gonna do? We'll take assumption. For all this kind of question, no, take assumption. Because then the work becomes very, very easier. Okay. Because they are also complementary functions. Check here. Tan and cot are complementary functions. So some results will come from there. Okay. Okay, sir. So let's see. Let me take the assumption here only. So I can write this as tan inverse of x equals to a. So basically tan a is x, tan a is x, okay. And next I want to write this as tan inverse of y equals to b So tan b equals to y, tan b equals to y, okay. All right, sir. Now how can I write? See, from tan inverse of x I want to go to cot inverse of x. Okay. So how can we use that? How can we use that statement? Now check here very carefully. Check here very carefully. So basically to reach from tan to cot, I have to use what? I have to use pi by 2 form. Correct, no? I have to use pi by 2 form. Acha, what does this mean? What is the meaning of this? Tan inverse of x is nothing but my angle A. So basically A plus B is 4 pi by 5. Okay, if you want to write this, you can write it here. Okay, you can write it here only. We have this much space only. So A plus B is given as 4 pi by 5. Not 45, 4 pi by 5. Forgive me. Yes, 4 pi by 5. This is my given condition. Okay, how will I write tan in terms of cot? Okay, so I can write this as x equals to, tan will be nothing but cot of what bacha? Cot of what bacha? Pi by 2 minus A. Check here, please check here. Cot of 90 minus theta is nothing but tan theta. Cot of 90 minus theta, tan theta, correct, no? So I'm rewriting tan as cot of 90 minus A, no problem. Tan A is cot of 90 minus A. So same way I can get from here cot inverse of x will become what? Pi by 2 minus A. If I'm taking cot over here, it will become like this. Same way I'll get it from here also. How will I write this? So y equals to cot of pi by 2 minus B. So if I do cot inverse, I'll get what? Cot inverse of y equals to pi by 2 minus B. Pi by 2 minus B. So this is my equation 1 and equation 2. Now see, that's what they're asking us to find, cot inverse of x plus cot inverse of y. So I will add it, equation 1 plus equation 2 I will do. I'll get what? Cot inverse of x plus cot inverse of y equals to what? Pi by 2 plus pi by 2 will be pi. Simply this pi by 2 will be added with this pi by 2, so pi, okay, because we are adding equation 1 and 2, and this will become minus A minus B. So pi minus A plus B. What is my A plus B value? 4 pi by 5. Check here. So replace this here. Pi minus 4 pi by 5. LCM you take 5 pi minus 4 pi by 5. Okay, how much is that? Simply pi by 5. Simply pi by 5. Simply pi by 5 is my final answer. That's what we're looking for. Cot inverse of x plus cot inverse of y. Pi minus 5. Which are pi by 5. Option A. Option A. Check here. Please check here. Pi by 5 is my option A. Just few more questions to discuss. Let's complete this. Let us complete this. Only 5 more questions are there. We'll complete this quickly. This is actually a PYQ. This is your PYQ. Can a question get simpler than this? Range of sec inverse fx. Sir, simply B. Simply B. Why, sir? Because if I find, can you find sec inverse at pi by 2? We cannot, sir. Why? Because cos is not defined at pi by 2. Cos pi by 2 is 0. So sec pi by 2 will be what? Undefined. Then how will you find sec inverse? Okay. So not possible. So sec inverse of x is this is the range, right? Range, right? 0 pi by 2, 0 pi minus pi by 2. Pi by 2 is not part of the range. So option B is correct answer. Moving on to the next question. Okay. This is same as that previous question. I hope whoever has solved this 25th question can solve this question also. 26th one also you can solve, right? 27th also you can solve, right? Same way. Sine and cos are given here and their complementary function. They're asking us to find cos and sine. In the previous one, if you see, tan and tan was given, they're asking us cot and cot. Tan and tan was given, they're asking us cot and cot. But in this case, sine cos is given and they're asking us to find cos and sine. But sine was operating here at, sine inverse operating at x, here cos inverse is operating as x. So no problem because they are complementary functions. So first do the assumption please. We'll do the assumption here only. So sine inverse of x. For any type of this question, what I said, do the assumption, take the angle first. So first you take the angle, make the assumption, then proceed with the question. So sine inverse of x equals to A. Okay. Then x equals to sine A. Same way. Cos inverse of y equal to B. So y equal to cos B. Y equal to cos B. Correct? Am I right? Y equal to cos B. Correct, sir. Okay, sir. Now we are looking to find cos inverse of x. Cos inverse of x. How can I write this? And one more thing, we can write from here only. Sine inverse of x is what? A. So I can write from here A plus B is equal to 2 pi by 5. One of the equation, this is the given condition. This is I've taken as A, this I've taken as B. So A plus B is 2 pi by 5. A plus B is 2 pi by 5. Okay, sir. Now, x is given as sine A. X is given as sine A. Not given, my assumption. So how will I write this in terms of cos? Simply like this, sir. Cos of pi by 2 minus a. Correct? Cos 90 minus theta is what? Cos 90 minus theta is what? Sin theta. So cos pi by 2 minus a is sin a only. Bring this cos here. So cos inverse of x will become pi by 2 minus a. This is my equation 1. Check here. Why equation 1, sir? Because we were looking for cos inverse of x and we got here cos inverse of x. So next we will take y equal to cos a. Check here. Not a, b. Cos b. Y equal to cos b. Check here. Y equal to cos b. From here we have taken. Now do one thing. Write cos in terms of sine. So again same thing, we'll write sine of pi by 2 minus b. Why, sir? Sine pi by 2 minus theta is cos theta. Sine pi by 2 minus theta is cos theta. Okay, sir. Take sine inverse on this side. Sine inverse of y equals to pi by 2 minus b. This is my equation 2. This is my equation 2. Add them. Why add them, sir? See the sign here. We are adding cos inverse and sine inverse x. Sine inverse y. So add them. We'll get what? Cos inverse of x plus sine inverse of y equal to what, bacha? Pi by 2 plus pi by 2. Simply pi and minus a and minus b. Okay. So pi minus a plus b. Okay. What is my a plus b value? 2 pi by 5. 2 pi by 5. Write it here. So this becomes pi minus 2 pi by 5. Answer will be 3 pi by 5. 3 pi by 5. 3 pi by 5. Check here. Please check. 5 pi minus 2 pi will be 3 pi. 5 pi, 5, if you take LCM, 5 pi by 5 will become 5 pi minus 2 pi will become 3 pi. 3 pi by 5 is my answer for this value. Okay. Cos inverse of x plus sin inverse of y. Question is done. 27th also is done, sir. Let's move on. Okay. Let's move on. 28th. Okay. This question I have done in my regular classes also. Okay. I have done in my regular classes for ITF. Correct? I hope you have solved it. So sine inverse of greatest integer function of x. GIF is given here, right? Greatest integer function of x is given. So let's look at the graph quickly of GIF. Okay, if I have to look at the graph of GIF, how will it look like? So over here, open, over here, open, closed, open, close, like this. What is these points? These points are what? These points are 0, minus 1, this is also minus 1, minus 2, this is minus 2, this is 1, this is also 1, okay, this is 2, this is also 2. Okay, I hope you get it. So basically whenever I have a value between 0 to 1, let's say I have 0.8 and I put GIF on this. What is GIF? Greatest integer function. If I put GIF or greatest integer function on 0.8, answer is what, bacha? Answer is 0. Answer is 0. So this is, you can see here, the value of this value from 0 to this, a value just before 1. Just before 1 is 0. If I put just 1, what will happen? Answer is 1. Check here, at 1 answer is 1, sir. Answer is 1, sir. Okay, sir. Okay, sir. Yes, sir, it is correct. Okay. Okay. Now what about 1.1? What about 1.1? Sir, answer is again 1. 1.1 will come somewhere here. Answer is 1 only. Check here. This is the answer, no? This is the answer, right? If I take 1.5, what is the answer? 1 only, sir. If I take 1.999, what is the answer, sir? 1 only. But if I take 2, what is the answer, sir? 2. Answer is 2. So right before 2, any value you put, answer is 1. Okay, sir. Why we need this, sir? We'll see. Okay. So we know that if it was not written like this, instead of writing is our sine inverse of GIF of x, if I replace this GIF of x as some other variable, let's call this to be a, sine inverse of a, then what is my domain here? What is my domain here? A is simply this. A is simply this. Domain is minus 1 to 1. But this is not a, right? This is not a. Now what is this actually? This is my GIF of x. So I can write this as, so far we have got for the value that the greatest integer value of x will lie between minus 1 to 1. But are they asking that? No, they are asking us domain. Domain means they are asking us value of x. Okay. So when will be x always less than or equal to 1? Check here. If you put any value less than 2, if you put any value less than 2 in the GIF, it will always come as 1. If you put 1.999 also 1, so any value less than 2, forgive me, any value less than 2, so any value less than 2 for what is for GIF? No sir, for x. For any x less than 2, the answer would be 1, which is completely true. Okay sir, what about minus 1? It will be just minus 1. How sir? Check, please check. If I put what? Minus 0.8, what is the answer? Answer is minus 1. Answer is minus 1. Okay, answer is minus 1. What about if I put minus 1.5 in the GIF? Answer is minus 2. Answer is minus 2. Okay, so to get the value equal to minus 1, I can put any value from minus 0.00012 minus 0.999. That is nothing but minus 1 only. And at minus 1 only, also, if you have to rewrite this, let me rewrite this over here so that it makes sense to you. For any value starting from minus 0.0001, or not even that, you can keep going like this up to what value? Up to 1, up to minus 1. For all this value, if you put this 0.0001, put GIF, answer is 1, minus 1, sorry. And if you put minus 1 in the GIF, answer is again minus 1. So for all these values, it is minus 1. So I can put an equality over here. So what is my x value? X starts from minus 1 to 2. This is my domain. This is my domain. That's what is domain, right? What the value of x is called my domain. So basically x belongs to what, bacha? Minus 1 is closed and 2 is open. Minus 1 is closed, 2 is open. Which option is this? B. Minus 1 is closed, 2 is open. Option B. Okay. I hope this is clear. Clear? Okay, sir. Moving on. Okay, sir. Moving on. 29th. Again, this question I have done. X plus 1 by x equals to 2. Find the value of sine inverse of x. So if x plus 1 by x is equal to 2, it means x square plus 1 equals to 2x. We have taken x or multiplied everything by x. So I get x square plus 1 equal to 2x. Rearrange it. X square plus 1 minus 2x is nothing but equal to 0 actually. Is nothing but x minus 1 the whole square. Don't ask how. A square b square minus 2ab. So I get x value as what, bacha? X value is simply 1. What are they asking? Sine inverse of x. They are asking us sine inverse of x. Sine inverse of 1. What is that? Pi by 2. Sine inverse of 1 is pi by 2. Answer is pi by 2. C. Answer is C. Please check here. Answer is C. X is 1. Sine inverse of 1 is pi by 2. Okay. Okay. Now last part. Cos inverse of. I think I've done this question also. Not sure, but I think I've done this question. Okay. Okay. I have this much space only to solve this. Let's solve this. Okay. We know this property. Cos inverse of minus x. What is this? Pi minus cos inverse of x in the domain, obviously. Same thing goes here. Sine inverse of minus x is nothing but minus sine inverse of x. I hope you know this. Formula I've taught you this. Right? These relations I've taught you. The properties of sine or ITF, I've taught you this. Please recall all these concepts. Please recall all these concepts. As you can see, whatever we have learned is becoming useful to solve this mock series. So make sure that you have learned all the concepts. Okay? All the concepts. Bacha. Sine inverse of minus x is minus sine inverse of x. In the domain only. In the domain that is given for cos inverse and sine inverse of x. Okay, sir. Okay, sir. Let's see. So we'll apply these concepts in the formula. So if you compare this with this, what you're getting? Cos inverse of minus 1 by 2 will be nothing but pi minus cos inverse of 1 by 2. Correct? Cos inverse of x. So 1 by 2 will be like this. And plus, what is this? Plus 2 will remain same. And this will become what? Minus sine inverse of 1 by 2. Don't ask what I'm doing. I hope you understand this from here. I'm applying sine inverse of minus x formula because x is minus 1 by 2. Sorry, x is 1 by 2. So minus x will be minus 1 by 2. This is equal to minus sine inverse of x. Minus sine inverse of x. So I'm applying that. Minus has come out. Sine inverse of 1 by 2 is there. Okay, sir. So if you look at here, this becomes what? Pi minus cos inverse of 1 by 2. Cos, where is the cos 1 by 2? Cos is 1 by 2 at pi by 3. Pi by 3, right? Yes, sir. So this will become what? Simply pi by 3. Now plus 2 times of what? minus sign is there, so I can write this as simply negative. Please check. This is negative sign, this is plus sign, so minus sign. Okay, sine inverse of 1 by 2 is what? Pi by 6. Pi by 6. Simplify this, please. Pi minus pi by 3 minus pi by 3. Answer is going to be what? 3 pi minus 2 pi. Answer is what? Pi by 3. Answer is what? Pi by 3. Option A. Option A. Pi by 3 is my correct answer. Option A. Pi by 3 is my correct answer. Please check here. Okay. So this completes our first mock solution. Okay, so I hope all of you have performed very good. If not, then make sure that you know what your mistakes are, where you're lagging, whether you need conceptual, are you making conceptual mistake, or are you making mistakes in accuracy, have you forgot the property? So you should know all these answers. Okay, like what actually is the reason behind loss of marks. So make sure that you analyze your paper. Okay, it's very important. If you make your own analysis, no, then you'll get to know and perform better in your coming mocks. Okay, but I really hope that you have all done very good. Okay, so this concludes our first mock session solution. Okay, in this we have covered relation function. We have done so many questions, lot of PYQs, and we have also covered questions from ITF. I hope this was good. I hope you understood all the solutions of all these 30 questions, and I'll see you in the next session. So far this has been really good. Okay, I like this session today. So take care, keep working hard, and I'll see you in the next session. Just make sure that you are working really hard, and that's all for today. So I'll see you in the next session. Bye. Take care.